Okay, for the first question, one randomly selected male, what's the probability that the weight is less than 185? So it's a normal CDF, guys. You put a lower bound, upper bound, mean, and standard deviation. Then we go to the second one. What's the probability that one randomly selected adult male will weigh more than 190 pounds? Again, same thing. It's one person. We're not doing samples here. So you just do a probability of X greater than, and then you do the normal CDF thing. You put the lower bound. The lower bound should be the 190. The upper bound is the million, and then put the mean and standard deviation. For part C, what's the probability that one randomly selected adult male will weigh between 175 and 200? This is your lower bound, guys. And this is your upper bound. And you answer it. Now, D and E. This is section 5.4, the central limit theorem, right here. Suppose 25 adult males are selected. You see, it's not one male, it's 25. What's the probability that they have a mean weight of more than 190 pounds? So the difference, guys, between B and D, instead of X, you're not gonna put X, you're gonna put what? X bar. So can someone tell me what's going to change in the answer between B and D? Nothing going to change except for what? The standard what? Deviation. When you put the standard deviation, you make sure to put the standard deviation divided by square root of n. And what is n in here? It's 25. That's the difference. For part E, suppose 36 adult males are selected at random. What's the probability that they have a sample mean weight of less than 168? Again, guys, you need to do probability of X bar less than 168. Not X, it's X bar. And you put the normal CDF thing. The only thing you need to change at the very end, different from previous problem, is at the very end, you have to put sigma divided by square root of n. And your n here is 36. For part F, what weight would place an adult in the top 15%? A top 50, so he wants X here, guys, and you must use inverse norm to find X. And a top 15% of weight should be here. That's the 15%. And that's your X value. I'll let you find this one. So this is the assignment. Should take about 10 minutes, guys, to get it done with my hints. I'm going to be surprised if students don't get full mark on this, but I'm supporting you. I'm trying to help you out, guys, to show you how to write, because it's very important to express, not just your answer in writings. You print this out, or if you don't want to print it out, you can just provide the answers on a nice clean sheet of paper and then scan the paper using Genius Scan, and then save it as PDF and upload it to Moodle. So here's an additional handout covering chapter 5. I'm gonna do 14, which covers the central limit theorem, section 5.4. Assume that women's height are normally distributed, with the mean given by 63.6 inches and a standard deviation of 2.5 inches. If one woman is randomly selected, what is the probability that her weight is less than 64 inches? Okay, let's do this. So probability of X less than 64. Okay, help me out, guys. Normal, CDF, then what?
Negative a million.
Negative a million.
64.
What's the mean?
63.6. And 2.5.
That's it. And I'll let you guys find the answer. I'm not gonna do the answer, so you can do it. Now watch part B. If 36 women are randomly selected, What's the probability that they have a mean way height? It's about X bar less than 64. It's the same question, less than 64, but it's about the average of the 36 women. It's not one woman now. So here's how you do this. This is section 5.4. You see, guys, here we did probability of X less than 64. Here, X bar less than 64. It will be just like before. Normal CDF, negative a million, 64, 63.6, and pause here. Be careful here. It's not going to be only 2.5. It's going to be 2.5 divided by what? Square root of 36. I hope, guys, that I'm giving you a good feel of the difference between the two situations. And you can do the answer. If one woman, look, once I say one woman, guys, it's not the central limit theorem. It's just probability of X. X refers to one. X bar refers to many. Look, in B, it's 36. It's many, so it's X bar. If one woman is randomly selected, what's the probability that her height is between 60 and 65? That's an easy question. So you put 60 less than X, less, and this is how I like to answer the assignment. And then you put, show me that you put normal CDF. So I know that you knew how to use the right formula. You put 60 as a lower bound. You put 65 as an upper bound. And you put 63.6. And you put 2.5. Just the standard deviation here because it's only one person. And then you find the answer. So that's central limit theorem. Let's take you back to I'm going to do number 9 now. The Wilshire Adult Intelligence Test Scale is composed of a number of subsets. On one subset, the raw scores have a mean of 35 and a standard deviation of 6. So that's the mean, guys. And standard deviation is 6. Assume these raw scores are normally distributed. What number represents the 65th percentile? Who can answer this question? When I say 65th percentile, guys, that means I'm giving you the area to the left. This is the probability. So we need the X value. When he says what number, he wants the X value. So what would that be? X is inverse norm. And a percentile is already an area to the left. So you don't have to worry about subtracting from 100% or nothing. You just use it as is. So that will be 0.65, guys. And then you need the mean, which is 35. And then you need the standard deviation, which is 6. And that should give you the X value. Okay. I need someone now to tell me how to do B, which very similar to A. So who can answer B? What number represents the 90th percentile? Don't be shy, guys.
0.90?
Yeah, inverse norm, 0.90, and then what?
35 and 6.
Yeah, 35 and 6. What is the probability? Look, guys, we're back now. What is the probability? Once I ask you for the probability, or if I ask you for a percent, or if I ask you for a proportion, guys, it's a probability of getting a score between 28 and 38. It's the usual norm. Which is normal CDF. 28, 38. What's the mean here? 35 and 6. And then you can find the answer using your calculator. D, what's the probability of getting a raw score between 41 and 44? Same thing. You put the smaller number first, guys. You put the less than, you put the X, then you put less than 44. And then you do normal CDF. 41, 44, 35, and 6. Okay, we'll do 10 now. 10 covers section 5.3. This was section 5.2 and 5.3. 5.3 to find the X value. He will give you the probability and he'll ask you to find the X value. Okay. Scores of the set form a normal distribution with the mean of 500 and standard deviation of 100. What is the minimum score necessary to be in the top 15%? Would you guys agree with me if I tell you the top 15% should be on the right? And we need this value. To be considered a top 15%, you have to be above average, guys. This is the average. The average is always right here in the middle, guys. So who is going to answer this question for us? It's an inverse norm.
0.85.
Excellent. 0.85. 0.85. I think one or two of you guys have a calculator that has at the bottom right, left, and middle. In this case, all you need to do is select right and put 0.15. The calculator knows what to do. But if you don't, you must provide the area to the left of the target, which is this area right here. And then the mean, guys, is 500. And the standard deviation is 100. I'm going to do this one to show you that the answer has to be above 100. Above 500, I'm sorry. Be in the top 15%. 603.64. There you go. Find the range of values that define the middle 80% of the distribution. This is in U, that's why I wanted to do this one. So I'm gonna allow some space for this. All right. And let me show you how to do this one. Middle 80%. All right. Look, how do you deal with the middle? Let's say he says middle 80%. Look what you do. You need the 80% in the middle. This is 80%. All right. Okay, we need this value, guys, because there are two values in the middle that splits up the middle, and we need this value. Can you guys tell me if 80% is in the middle, what percent goes to the left and what percent goes to the right? What's left?
10% on the left.
10%, I agree.
On the right.
And then another 10% what?
On the right.
Yep, very good. Okay, who can tell me how to find x1? The first value. Inverse norm. Okay. What's the area to the left of x? Right
10.
here. 10.
0.10.
110. And then put the mean 500 and put the standard deviation 100, and then you can find it. Let's find the other value. The other value has to be larger than the first value, larger than the mean. This is the mean, guys. That's a 500 right here. Okay. Who can help us do the second one? Inverse norm. What's the area to the left of the target for of x?
0.9.
0.9. Very good. And then you put the mean, which is 500. Then you put the standard deviation, and we close it. And that should be the answer. So here's the hint, guys. when I teach this in class, students will ask me, is there a shortcut rather than doing this? I tell them, yeah, definitely there is a shortcut to do it. So this is what I tell students. Let's say they ask us to find the values in the middle 70%. Look what you do, guys. Please listen carefully. Take the 70% and subtract it from 100. You will get 30%. Divided by 2, you get 15%. So here's what you do now. You do an inverse norm, 0.15, mean, and then standard deviation. And then the second one will be, guys, 100% minus 0.15 will be 85%. Then mean, then standard deviation. Let's see if that worked here. He wanted the middle 80%. So subtract 80 from 100, you get 20. Divided by 2, you get 10%. We did the 10% right here, guys. Then what do we need to add to 10% to get 100%, the 90%? We did the 90% right here. Mean and then standard deviation. Okay, so this is about inverse norm. Let's see. I want to do number 7 now. The monthly income of 5,000 workers at a Microsoft plant are distributed normally. Suppose that the mean income is 1,250 a month and standard deviation is 250. I know, guys, these figures are not accurate because I'm sure you can make a lot more than this at Microsoft. How many workers earn more than $1,500 per month? How would you find out? There are 5,000 workers at the factory, guys. And the mean, the average income is 1,250 and the standard deviation is 250. We need to know how many workers make more than $1,500 per month. How would you figure this out? Any ideas? Before you do this one, guys, here's what you need to do. I could have asked you, what's the probability that a randomly selected workers make more than $1,500 per month? So you will find this. So let's find, first of all, the probability that someone makes more than $1,500 a month. What's the chance? What's the percent? So that will be a normal CDF. 1,500, a million, or billion, then 1,250, and then what? 250. Okay, let's see what the answer is. So I'm gonna do it, guys. Second distribute. I believe everybody should know how to use the calculator by now. 1,500, comma, 1 million, comma, 1,250, comma, and then 250. Okay, I got 0.1587. But that's not the question, guys. The question is, he says, how many workers make more than 1,500? What do I do with the 0.1587? I have 5,000 workers at the factory.
Multiply it by 5,000.
Exactly. So when he asks you how many, guys, you need to find the probability first and then multiply it by the number of workers. So it will be 5,000 times. Okay, let's see. So it's about 793 workers. How many workers earn less than 750 per month? It's the same thing, guys. We're gonna do probability of X less than 750 first, which is normal CDF, negative a million, 750, 1,250, and 250. Let's see what the answer is. Second, and distribute. So I go to my calculator. So negative a million 750, 1250 is the average, and 250 is the standard deviation. I got 0.0228 if you're following with me. It's a very small percentage. And again, guys, to figure out how many workers earn less than 750, you take this percent and multiply it by 5,000. I got 114. Okay, what percentage of the workers earn between 750 and 1,500? When he says a percentage, guys, it's a probability. So don't mix it, don't confuse it with anything else. It's a probability. So he wants probability of X between 750 and 1,500. And you already know how to deal with this. It's normal CDF, 750, 1,500, 1250 is the mean, and standard deviation is 250. Okay, let's do this answer. Normal CDF. I'm sure you're tired of hearing the normal CDF today. We used it quite a bit. But I wanted to just do as much practice as I can. 1250 and then 250. Okay, you get 0.8186 if you round it. But if you enter this answer into my math lab, it's gonna mark it wrong. Why?
It needs to be a percentage.
It needs to be a percentage. Very good. Thank you very much. So you need to change to a percent.
81.86.
81.86. And usually my math lab will put a percent sign, guys, for you. All you need just to enter the 81.86 and that's it. So the only reason, guys, why I put this question in there, because I want to show you if it is a percentage question. It is probability, but just change it to a percent. Let's see this one here. What percentage of the worker earn less than 1,750 per month? Same thing, guys. We're going to do the probability. And we're going to do normal CDF. Negative a million or a billion. Even zero will do it here. 1,750. Mean is 1,250 and standard deviation is 250. Okay, so I'm gonna do it. I'm gonna do the answers, guys. So if you do this practice again, you get feedback with the answers as well. Probably after, as a result of this exercise, nobody wants to work for Microsoft because the earning is so low, but I made up those numbers, guys. They're not true. And need to change it to a percent. So there will be 97.72%. Okay, I'm gonna stop sharing here and we're gonna do this exercise and